Okay, so now that we have the tools to make the robot, we're actually going to make the robot now. So first thing first, make sure you have your project file selected. Okay, so now let's go and create a new assembly, because the first step of laying out or of making a robot is laying it out. So we have a sketch, right? We have an idea of what we want it to look like, but now we need to actually kind of lay it out in that orientation and figure out hard dimensions, constraints, things like that. So let's go ahead and place all of our standard components. Okay, so now that our standard components are placed, we can, well, first change our view to shaded with edges. Now, like I said before, you need to ground something, so I choose the battery. And so here we can start putting in all of our parts, because this isn't all of them. We need 2 drive motors, we need 2 wheels, okay? So now let's lay things out very roughly. And so if you notice, I can drag this around. Say I want it in the corner of that battery. Well, if I actually pan around, it's not in that corner of that battery. So that shows us that we need to kind of do it on the planes. So if I want to make it in the corner of the battery, I have to do it from 2 views rather than from the 3D view. And so if I look, now it's actually in the corner of the battery. So what we want to do is rotate things around. Okay, I just click this free rotate button up here, and I'm just going to kind of very roughly orient things. This just makes it easier to apply constraints. And the orientation of everything that I chose here is just kind of going from wanting to package things as tightly as I can. So I want to make these electronics touch up right against the battery. I want to put the switch right in the corner there. I'm going to make the motors kind of as close to those electronics as possible, so it's as tight and compact as can be in order to save space. And I know that I'm making a vertical spinner, so the weapon motor needs to be horizontal. And actually, another thing to note is the wires here. See, right now they're pointing outwards, and so if we were to attach it like this, the wires would have to go out and then route back in. It's kind of annoying, so I'm just going to rotate this around as best as I can to get the wires towards the inside. And so now what we can do is lay things out more precisely. Okay, that's pretty rough, but that's what our robot is going to be laid out like. So let's start applying constraints while still giving it some freedom to move. Um, so for example, these weapon motors or drive motors and the wheels, I know that it has to be on the same shaft, so I can do that with a make constraint. Uh, So if you ever have a wrong constraint, just undo it, or say you had a wrong constraint that you did previously before you did other constraints. What you can do is you can select the piece that you know to have the wrong constraint on, come over here, select the constraint, and delete it. So now it's free to move again and free to rotate. So let's continue. Okay, let's take care of the electronics now and just kind of bunch them together. Okay, so this here is what we want eventually. We want things to be really tight, compact, not able to move at all, fully constrained. So let's do that for the rest of the components here. And for the wheels, we know they should be in line with each other, right? And they should also be, the axes should be parallel. Oops, I don't know what happened there. The axes should be parallel to the battery itself. And we can do an angle constraint on that. And just kind of play around with the angles and hopefully it snaps together. You might have to try something different, but I'm just going to go from there. And if you ever, like, so now they're really weirdly oriented. If you ever want to rotate things while it's still constrained, you can do that, and you can select multiple items to rotate at once, right? And then all you have to do after that is go up here to this orange button and hit update, and it re-snaps the constraints together, right? So let's continue with some constraints. Okay, so now that we're pretty close to having things pretty fully constrained, let's add a few more parts in here. Well, one more part, which is the weapon actually itself. You notice that I made this big cavity, but I'm not sure exactly how far in to make it because I don't have the weapon yet. So let's go ahead and make the weapon. Okay, so I'm in a new sketch in the weapon file here, and I'm just going to kind of put the hole for the press vent, because if you know what outrunners are, you know that this is a motor, but the shaft isn't the only thing that spins. This entire outer shell spins with the shaft. That's what it's called that's why it's called an outrunner. And so what we can do with that is we can press fit a weapon onto this outer shell here, and it'll spin with it. We don't have to do any kind of shaft collars or anything like that. We just literally clamp this on basically. And so to get that dimension, we're going to use what's called the measure tool. And the easiest or the proper way to get to that tool, I guess, is to go to the inspect tab and use the measure button here. Or what you can do, and I prefer this, is to right click and just mouse over to measure. Or there's a shortcut where if you right click and hold and just drag over, it'll to where you know that option to be, it'll select it, so measure. And this measure tool is pretty handy because you can measure, we'll say you want the radius or diameter of this cylinder. You can click it and it'll give you the radius, diameter, total loop length, area, everything you need. If you want a distance, you can do the distance from this face to this face, or the outer distance of this face, or the outer diameter of this circle. Or if you have points, you can go from point to point, or you could go from center of a hole to center of hole, and it'll give you that distance. It's pretty useful. So let's get the radius dimension of this cylinder, and let's go use it. And that's going to be the radius dimension of our hole. And I kind of have a rough idea of what I want the weapon to look like, and so I'm going to sketch that out. Okay, so this is roughly what it's going to look like. Let's add some constraints. And I want it to be symmetric across both sides, so I'm going to make everything kind of equal. Okay, so now it's shaped the way we want. Now we just need to put the dimensions in. So I'm just going to make it 3 inches long. And I'm going to make this section here 3/4 of an inch tall. And I'm going to make the gap between the two, between the weapon motor and the outer shell. This is going to be, I don't know, 0.3 or something like that. That looks pretty good to me. And it's all blue, it's all constrained. So now what we can do is we can extrude that. And another tip here is there's a symmetric extrude. So if I want to extrude this 0.875, say, I can make this a symmetric extrude, and it'll extrude evenly on both sides to make the total extrusion to be 0.875. This is very nice because now we have a plane that goes right through the center, and this will be useful when constraining this in the assembly. So let's save this. And let's place it in. Add some constraints. And another constraint to note is that we can't have this too far down because the actual edge where the outrunner shell stops is kind of right where my cursor is. So if we make it too far down, it'll actually rub against something that's static, and that'll just create a lot of friction, and our weapon might not even spin. So I'm just going to constrain it to this top edge here to give it more than enough space. Okay, so now everything is kind of looking in place, so let's add some more constraints. And I want to make this, the plane that we saw, the origin plane of our weapon motor, be in line with the very center of this battery. So I need to make a plane at the very center of this battery. Well, actually, let's check the origin planes. No, see, there's no plane through the very center of the battery, so we need to make that. And I'm going to do that by doing an offset plane. So if we get the total distance of the battery, copy that, and make an offset plane from one of these faces of negative that distance divided by 2. It'll be right in the center. And so now we can take this weapon, make the origin plane visible that we want to work with, and we can constrain those two planes together. Okay, so now it'll always move. See, I can't move it side to side. It'll always move in line with that. And so let's hide those planes because they are kind of annoying. And let's do some more constraints. So when this spins, there's going to be kind of a circle, an area of effect that it will have, and we don't want any of our parts to be in that area of effect. That area of effect is defined by the largest distance across any 2 points on our weapon here, and I know that is from this corner to this corner. So this distance is the diameter of the circle area of effect. So what we can do then is give the electronics at least that area of effect clearance. I'm going to take into account the thickness of the wall, which is going to be 0.125. Let's take into account some clearance for the wires, and let's take into account some more clearance for the for some space on the outer edge for tolerance. And so that's a dimension that we want to have there. Okay, so now we can't move it back and forth. We just can only move it up and down. So now we're going to get into ground planes. And a ground plane is literally exactly what it sounds. It's the line, the plane where the ground is, which is going to always be at the bottom of these wheels. So we need to put a plane at the bottom of the wheels. To do that, it's kind of tricky. You kind of have to play around with the planes. And so what I'm going to do is I'm going to make one at the center of this motor, and then I'm going to make an offset plane from there to the bottom of the wheel. So let's go ahead and do the same technique we did with the battery. Get the distance, total distance that we want it to be in the middle of. Copy that, and actually I think we can click this now. Okay, so let's offset from here. Oops, try that again. Offset from here, negative that distance divided by 2. So now we have a plane in the very center of the motor and very center of the wheel. So we can do an offset plane from that plane. And I know this wheel is 40 millimeters in diameter, so I need to go negative 20 millimeters. Hit OK. And if we look, we now have a plane at the very bottom of our wheel. That's our ground plane. So now we can reference things from that plane. Like we want the clearance of the robot itself to be about 0.2 inches. And so this battery I know is going to be on the top of the base plate. And so if we can dimension off of that, right? So the base plate is going to be 1/8 of an inch thick. And then we also want 0.2 inches of clearance. Okay, so we're getting some more dimensions in here. Things are starting to look better. And what we can also do is dimension the height constraint of the weapon motor. And I want that to be, oh shoot, I need to get the area of effect again. And so the measure tool, again, you just right click, move over to the tool you want, and there's the measure tool. Copy that. So I want the bottom of this weapon to be at the bottom of the base plate. And so we just need to add, or subtract, I guess, 0.125 inches, or add 0.125 inches for the thickness of the base plate. Okay, so now this is fully constrained right here. The only things that aren't constrained are the switch and the distance, these two constraints for the wheels. And so let's do the wheel constraints. I know that, well, if we look at our example bot, I know that there's kind of a wall right here, let's say. Alright, so let me sketch this out for you guys. So there's a wall that's going to be right here, right? And that's going to have bolts that mount to the weapon motor. And so we need to add some clearance in this little section here of about 1/8 of an inch. That's a terrible 1/8 of an inch, but you get what I'm saying. And then over here, so that means we're going to reference or do a mate constraint from the drive motor to the weapon motor. That's going to be the 1/8 inch thickness. That is the wall here, an 1/8 inch thickness for clearance, and then that'll be our constraint. And so on the other side, we're going to reference it off of the weapon itself, right? So there's going to be a wall kind of right here. These walls are terrible. You get what I'm saying? So there's going to be a dimension or a constraint from this point, this face to this face. That's going to be an 1/8 inch tolerance clearance, 1/8 inch thickness of the wall, and 1/8 inch wire clearance. And then what we can do is draw in the rest of our bot, which is going to kind of look like this, except, here, hold on, give me a second. We're going to make it tight to the electronics. I forgot. So we're going to come in like that. You get what I'm saying. So that's going to be the outline of our bot, and we're going to have these walls that are jutting out, which are going to protect the weapon motor and also mount the weapon motor. So let's go do that. So we want the mate constraint. That's going to be an 1/8 inch thickness for the wall, plus an 1/8 inch thickness for the wires, or clearance for the wires. And for this side, 1/8 inch tolerance, 1/8 inch wall thickness, 1/8 inch wire clearance. Excellent. So now there's only one more constraint for these, and I just want this to be kind of as far back as I can without getting to be annoying. So I'm just going to say there, and I'm going to snap it to a dimension. So say this dimension is 1.38. What I'm going to do is I'm going to create that dimension, but make it 1.38 of an offset. Or a more neat dimension would be a better number. So 1.25, 1 1/4. Actually, I don't want that. I want to make it a little further out. So I'm going to add 1/8. Excellent. And with the switch here, what we can do is just add a couple random constraints here. Sure. And I realized I want these drive motors to be out just a little more, so I know the constraint is on this drive motor. And I'm going to edit the distance, and I'm going to make it -1.5 instead. And I'm going to call that good. So the only thing that's not constrained is the drive weapon motor rotation, right? And I know I want it to, I want the wires here to be kind of parallel to the ground plane here. So it's going to look like that. So let's add a constraint for the weapon motor. Just pulling from an origin plane. That just makes it easier, and I'm going to make that parallel. So 0 degrees offset from or I could even do it from the ground plane. Excellent. Okay, everything's constrained. Let's go ahead and build our shell around it in the next video, after we save this.